Welcome back to Environmental Science. Last couple of days we've talked about the experimental method. The experimental method or the scientific method starts with observation, which is information gathered with your senses. We then go on to the hypothesizing phase, which is a testable idea based on data, and it should make some form of a prediction as to what the outcome is going to be when you make a change in your variable. Then we go to the experimentation phase, which is a procedure designed to test that hypothesis. It should test just a single variable from your group. You have an experimental group where the variable is changed, and then you have a control group where the variable is unchanged. As you're doing the experiment, you are gathering data, which is simply information, usually in numerical form, and then we're going to organize that data, classify it, analyze it, and try to figure out what exactly is going on as our experiment is taking place. We then draw our conclusions. Conclusion, and you're going to compare your hypothesis with your test results. Do they coincide or do they repel each other? You may have to do the experiment dozens upon dozens of times, so repetition is certainly a key portion of the experimental method. And then once you feel fairly comfortable with your results, you're going to communicate those results with others, usually through scientific articles. Not all science can be tested using the scientific method. We talked about a couple of reasons why. First of all, if it's based on a historical event, there's no way we can go back in time and test these things at that particular moment in history. And the second reason would be if something is unethical to try to experiment with. So when we do that, when we have those scenarios, we use the correlation method. The correlation method tries to connect a cause and an effect. However, keep in mind that just because there is an effect doesn't necessarily mean that the cause is what you think it is. And then we concluded yesterday with the scientific habits of the mind. Scientists tend to be very curious. If you aren't curious, you're not going to ask questions, you're not going to delve deeper. They're also very skeptical. They don't believe everything until they see it with their own eyes. They're open to new ideas. They have intellectual honesty, being capable of admitting mistakes, and they have a lot of imagination and creativity. They just think differently than other people. And that brings us to our topic today, which is statistics and models. So most of us have probably heard the term statistics, and you know it deals with numbers and maybe even facts. So statistics are a collection and classification of data in some sort of numerical form. That could be the batting average of individuals. That could be the heights of trees or the heights of plants on any side. It could be how fast something occurs. It could be the speed of a vehicle. Basically anything that is in numerical form that we've collected and classified. Now, once we have those numbers collected and classified, we can use them scientifically. One of the big advantages is the analysis and comparison. So we can group these things into different categories. Let's just say I'm looking at the effects of different fertilizers on plants. So I buy 100 pea plants, I plant them all, and maybe in 50 of those I use Miracle-Gro, and another 50 I use Black Cow. I'm simply making a comparison between what are the effects of those two fertilizers on the growth rate of my pea plants. So as I start growing them, maybe every day, maybe every other day, I take a measurement. What is the height of all 50 plants in category A and all 50 plants in category B? And I do that over a period of time. Each of those groups is what we call a statistical population. It's a group of similar things with different characteristics. So we have all these plants that are similar, but yet they're not exactly the same because I grew them using a different seed, but it is still something very, very similar. And so then I can compare my two statistical populations to see, is there a difference between Miracle-Gro and Black Cow? Now, oftentimes what we will do is we will use the average, or what we call the mean. Mean means average. And the way we find the average is we add up the particular characteristic measurement and divide by the number of individuals in that group. So in the case of my pea plants, I add up the heights of all 50 plants in each group and then divide by 50. Now, along with the statistics that I've gathered and I've figured out my average or my mean, I also want to figure out the distribution. Distribution is simply the arrangement of the characteristics in my population. So for instance, if I were measuring the heights of my pea plants, I'm going to have some plants in my group that are short. I'm going to have some plants that are kind of medium height. I'm going to have some plants that are larger. However, if I have a good statistical sampling, I'm going to have what we call a normal distribution, which is kind of the bell-shaped curve. We should have the vast majority of my plants in each group should have roughly the same height. And then there should be some that are a little bit taller than that, some that are really tall. I'm going to have some that are slightly shorter than my average, and some that are really short. But it should be a normal distribution. Normal distribution is always bell-shaped, and it's always symmetrical, or a mirror image, about its mean. Now, once I have that normal distribution, finding probability of an event is much easier. Probability is simply the likelihood of an event occurring. So once I have that statistical average, once I have my distribution figured out, I can take a look at, well, what is going on with these different things? What is the likelihood that I'm going to randomly choose a plant that is 3 centimeters taller than the average? A large sample, the sample being a group representing the population, has to be taken to get accuracy. The larger the sample, the more accurate your results tend to be. This is one of the reasons why when you do a scientific experiment, you want a large number of experiments. You're less likely to make errors. You're going to be able to see those, what we call outliers. If I only grow 5 pea plants, well, I may have 3 of them that die, and that only gives me 2 that survived that I can take measurements of. However, if I grow 50 pea plants, even if I have 20 of them die, that still gives me 30 of them that I can take my statistical analysis of. And so it's always better, the larger the sample, the better. What limits our sampling is often due to money and time. The more samples you have, the more expensive it tends to be, and also the amount of time that you have in order to do your experiment. Those tend to be the limiting factors. Statistics are used every day in life. So understanding the concept of statistics and how they are derived really helps us understand even watching the news. Statistics are often compared to an average. For instance, you might hear something like, the infant mortality rate is on the rise. Well, how do they know that? There needs to be some sort of analysis done. Are they comparing last year's number to the previous year? Or are they taking last year's number and looking at the trend over the last 20 or 30 years? So how do they derive that? Oftentimes that information is not given in a news report. They just make the statement and move on. However, you always need to be very discerning when you're listening to the news. The news media has an agenda, and they are going to push that agenda whenever they can. So having discernment and having that scientific habit of skepticism is always a good thing when watching the news. Even good people do have agendas and they want to push certain things. The better statistics are understood, the more discernment you are going to have. In this wake of COVID, there's a lot of statistics that are thrown out there on Facebook and on the CDC website, and you hear one thing and then you hear something that's exactly the opposite. Well, how can two opposing views both be right? It's based on the statistics and how they are viewing those statistics and what they are comparing those statistics to. That's why it's very easy to lie using statistics. And one of the things that statistics are really used for is for us to assess risk. Risk is any unwanted outcome. If it's risky, that means there is a likelihood that something bad is going to happen. So, if I were to ask, how much risk are major oil spills? For many people in the world, especially if it's right after a major oil spill that's made the news, they will say, oh, it is very risky. There's a lot of oil that gets spilled due to these major oil spills, and we need to do something to change it. However, in reality, they are a lot less risky than what we would normally think. Over 50% of the oil in the ocean today comes from land runoff. You driving your car, the little bit of oil that hits the ground, the rain comes down, washes that oil into streams and rivers that eventually make its way into the ocean. Over 50% comes from land activity, not even oil drills out in the Gulf. So we need to make sure that we have our correct statistics in order to really make a firm decision on these different events. Now, the biggest risk of all, of course, is going to be that of death. So why is that? Well, most people overestimate sensational risks. There are a lot of people that are afraid to fly because whenever there's a major airline that crashes, you hear about it in the news. But in reality, how often does that actually happen? There are a lot more deaths from cars and driving than there are from airplane crashes. And we've all heard that, but some people still are afraid to fly. Why? Because the news sensationalizes things. Nuclear radiation leaks. The only time you hear about nuclear radiation leaks is every time they happen. And think about how often they actually happen. Not very often, and yet people are very afraid of nuclear radiation. We underestimate other types of risk, such as smoking or alcohol consumption and what it does to your liver. Rip currents as we go to the beach, like, I'll be okay. So we underestimate certain risks, things that are actually very risky, and we overestimate things that are sensationalized. And that can be a major problem. So as review for today, we discussed what statistics were. Statistics are a collection of data that is analyzed and classified. We use those statistics usually to find a lot about a group by studying a small sampling size. We also arrange those and figure out the distribution, which is how the different individuals in our sample are arranged. We use the mean oftentimes to determine, is this above or below an average? Is there an increase or a decrease based on this change? We looked at probability, which is the likelihood of a certain event occurring or not occurring. Along with that, we looked at risk and risk any unwanted outcome. How risky are things really? In order to make that determination, you have to have the true statistics.